Hello there, children. Now we're going to work on items from Review 2, the questions that you, again, asked for. Now, this particular problem is oodles and oodles of fun. It's a rational expression, so how am I going to deal with this? Why, I'm going to find the LCD. Now, the LCD is the least or lowest common denominator of a problem. So if I wanted to add all these things up, what would I need to have in an LCD? So we should factor every denominator first. Hey, look, they're binomials, they're factored. Oh, happy days are here again. So I need to represent every part of every denominator. So let's think about that for a second. And I need to have an x squared, obviously. That takes care of all these x squareds right here. Boom, boom, and boom. That takes care of that. Now, I'm only doing this like this because everything is linked together with multiplication, so I can do this. Now, I have a 4, a 2, and a 4. Those LCD would be a 4. So if I wanted to add all these up, I would need a 4. Now what I'm going to do is multiply every single term in this particular fraction by that 4x squared, just to the numerator, because sharing is caring. Thank you, imaginary voice in my head. So we are going to do that. Every single term gets it. No complaints whatsoever. So I do it to the numerator only. Let us do that. Now, what's great about this is I'm going to get a little cancel happy here. Woo and who. If you do this right, every single term in your denominator should die off. Which in this case, they do. Now, thing here is I'm left with a 2 up top because 4 divided by 2 is 2. X squared divided by x squared, gone. 4x squared divided by 4x squared, also gone. Oh, happy days. So now I'm left with this. Oop, I don't want to use that. That's so silly. Let's go back to the pen tool. Now, 2 times this. Then I just distribute the 2. Now, you look at this problem when you're all said and done, in terms of combining things together. And I go, alright, well, I have just an x. That means I isolate just the x. I'm going to do the following. I'm going to bring the x's over to the left, or the right. I'm going to go to the right this time. Why not? And I'm going to subtract 3 from both sides. That's going to leave me with 2x minus x. X, 1 minus 3, negative 2. Now, what I must do with this negative 2 is check it in all my denominators. I can check it in the whole problem, to be honest. But the negative 2 can't make any denominator equal to 0. If it does, that is not a valid solution. But when I do that here, it doesn't make any of my denominators 0. Oh, happy days are here again. Moving on. Okay, this particular one, some people were not fans of because my LCD is a little complicated. I have an n squared, and an n. So I always take the biggest one for my LCD. So out of the n squared, the n, and the n, I need the n squared. Out of a 3, a 6, and a 6, I need the 6. If I wanted to add all these things together, I would need that. So I multiply that to the numerator of every single term. Just the numerator. I can do that because sharing is caring. And the fact that I'm doing it to every term. I'm not sliding a term. I'm not going like Oprah, you get a 6n squared. You get a 6n squared. Not you. That's not fair nor nice. Nor is that even legal in mathematical terms. So let's take a gander here. 3 divided by 6. It's going to be 6 divided by 3. That's a 2. N squared divided by n. That leaves me with an n. 6n squared over 6n squared. Bye-bye. 6 divided by 6. Bye-bye. N squared over n. N. Now, after all that variable carnage, what do I have left? I have an n plus 1 equals 2n. Well, In that case, I'm just going to go ahead and subtract myself an n from both sides. N equals 1. Now, does that make any of my denominators equal to 0? Let's pause that for a second and think. Nope. Good solution. Moving on. Alright, again, this particular problem. What's my LCD? I got coefficients of 3, 1, and 1. I am going to need that 3. K squared, and k squared. I'm going to need the k squared. And again, that goes to every single term, just to the numerator. For sharing is in fact caring. Just to the numerator. Just to the numerator that LCD goes. Because in the end, I don't like dealing with these fractions, and probably neither do you, to be honest. So why bother? If I can just kill them off, they're not people. I can kill them. So I get k squared, cancel out, I'm left with a 3. The k squareds cancel out, I'm left with a 3. Those 3's die off. The k divided by k squared is just a k. Now, here is where I get, or where I end up, rather. Distribute here, and I get k squared. Oh my. My indeed. I have a k squared for once. Huh. Neat. When you have a k squared, remember, when you have a squared term, that immediately screams you set it equal to 0. So let's drag this 15 over, shall we? Let's do that. And I'm left with this right down here. Alright, k squared plus k minus 12 equals 0. I need to factor that. Two numbers that multiply to negative 12, but add to that 1 out in front there. Well, a little arrow here. That's k plus 4 and k minus 3. When in doubt, you fool it out. You fool it out. But we don't have to do that here. You set each factor equal to 0, and we solve. Now, what I must do to both of these is check them in the denominator. If they don't work, that means they make the denominator 0, then they're no good. So this is the Imperial March time for this, because if these make the denominator 0, they're not a valid solution. So let's go ahead and check them for a second. Negative 4, making all those not 0. Goody gumdrops. 3, making all those not 0. Great success. Alright, we're moving on. Now, this particular problem is one that could cause you trouble. Remember, we talked about factoring all the denominators, but in previous problems I didn't have to do that. They were binomials. This I do. Now, why am I factoring these? Take a minute and factor. I know factoring scares people. Why did I factor this? What do I have to have in my LCD? I need a p minus 3 in the LCD. That takes care of that and that. I also need to take care of that p. So let's go ahead and do that. Which takes care of that p, but it also takes care of these two as well. So my LCD is really p times p minus 3. Now, if you're not careful, just go, well, I multiply that times that, and that's my LCD. About that. It will be a common denominator. I'm not going to deny that fact, but it won't be the least common denominator, and then that won't bring you the least amount of work, which is what all of you are kind of striving for here, I would assume. So each term, just in the numerator, like I've said at least 4 times already, this video, are going to get the LCD. And get it they shall. Just to the numerator. The Imperial March is playing for many fractions are about to be destroyed by the mighty Empire. Goodbye. Goodbye, P's. Hello, P minus 3. Goodbye. Now, after all that carnage, I'm left with a 1. I'm left with a P minus 3. And I'm left with a 3. Combine your like terms, and oh wow, look at that. Neat. Huh. Neat. As I do this, I get P equal to 1. Don't really have to do any work there. Huh. Nifty. Does P minus 1 work? Well, P equals 1. Good. Good. Good, not 0. Woo! Alright. Thus ends all your questions on review 2. That's all you asked for, gang. Oh, happy days are here again.